So on your quiz, you've shown me that you know how to graph um, given the equation of a parabola. I'm just going to wait for my pen to wake up. Good morning. It's coming. You can do it. Oh, I didn't plug you in. Okay. So if I write y equals 2x plus 1 all squared minus 4, we know how to find the vertex. We hopefully know how to use the step pattern or the 3.35 point method to draw multiple points and actually produce a graph. However, what if I give you an equation, still quadratic, that looks like this? So the first one, what is the name of the form of this equation? It is the vertex form. Why do you think we call it the vertex form? Everyone, out loud. Yeah, we can find the vertex. It's right there. -1, 4. -4. What is the vertex of this parabola? Well, I don't know. Is the vertical translation 10? I don't know. I'm just gonna guess it is. I don't know. So, what is the name of the form of this equation? Anyone? It is standard. Standard form means you have ax squared plus bx plus c. Now, folks, do you see an h and a k in that equation? No. So guess what? This is not our k, and this is not our h. We need to find them. We know the direction of opening, right? Is the parabola opening up or down? Is there vertical stretch or compression? Okay, so we know the A, but that is all we know about the parabola right now. So when you're given the equation in standard form and you are asked to graph it, you get a bit annoyed with Miss Sly because now you can't just graph it, you need to do some work. And it's not fun work. It's called completing the square. Luckily, you have learned half of it. Okay? Mr. Alexander covered partial factoring with you, and that is the first part of completing the square. It's not going to show up in the first example, but that partial factoring will show up in the second example. Now, I'm going to show you the process step by step. Okay, so I want us to write what completing the square is. So this new tool, completing the square. Okay, I'm going to call it tool. It's my new tool. What does it do? Well, it will convert. It converts standard into vertex form. So if I give you a quadratic equation in standard form, and I say graph it, you need to do some work in order to graph it. Yes? Going from vertex to standard, can anyone guess how we would do it? Sophie?
We define the H and the K, which you know it like H and K equals the vertex, and then you can maybe use a step pattern, like in the problem.
Oh, however, that's how you would graph it, but that's a good guess. But how am I going to get from vertex form to standard form? I'm given this. How can you find this? Yeah?
You can expand the bracket.
That's right. You take this bracket and you go x plus 1 all squared, and then you collect like terms and boom. So there really isn't like a name to that tool. It's just expand and collect like terms, right? So even now, you can go from vertex to standard. You have the tools to do it. But going from standard to vertex requires a new tool called completing the square. Now, I have it written out for you. I have the steps written out. So that's helpful, okay? When we complete the square, we change the quadratic form from standard to vertex form. So let's jump right into our first example. The equation given to us is this one. Let's rewrite it. Y equals x squared plus 6x plus 8. Now, folks, when I have standard form, I can't find the vertex from it, but what can I find? Yeah? I can find the A. What else can I find? I can find the y-intercept. Which other points? Think chapter 5. Yeah. Not yet. Yeah. Yeah. How do I find the x-intercepts from this? There's 2 ways. Yeah. Not yet. No. Yeah. I can factor, use the zero product rule to find where this parabola crosses the x-axis. What if I can't factor this equation? What would I do to find the x-intercepts? Yeah. Right? Because do I know what the A, B, and C are? I do. So I could find the x-intercepts, and then I could say, okay, I know the vertex is in the middle, and I'm going to find the middle, right? But I want you to know how to do that without finding the x-intercepts. So step 1, group the terms containing x using square brackets. All right, so that looks like this. Step 1. Woohoo! Step 2, this is the ugly, confusing part. I'll choose a nice color for it, purple. Complete the square inside the bracket. So inside this bracket, we have to do some work. This involves finding the number that would make this binomial a perfect square trinomial. So let me show you, bear with me. Okay, so I'm gonna keep everything the original color. I'm gonna open. Oh wait, let's do our, side work. Okay, so take the coefficient of x. What is the coefficient of x?
1.
No, in this equation. X, not x squared. 6. So my coefficient of x is 6, right? Draw an arrow for you to know, what did I just do? I took the number in front of the x. Check mark. What do I do to it? Okay, I'm going to divide it by 2. And I'm going to square that whole thing. Not square root, square. So I take the number, divide it by 2, square it. 6 divided by 2. So I'm going to do 3 squared, which is 9. So this process is new and confusing and difficult, and let's see why we even did that. So going back to our equation, we're going to do this. Then you add and subtract that number inside the square bracket. So I'm going to keep it color-coded. And I used purple for that new number. So what do I have to do with it? Well, I have to add it and subtract it. And then don't forget, was there something after the square bracket? Yeah, there was a +8. So let's just pause on this little piece. You still might not know why we're doing it, but tell me why I did +9 and -9. Yeah, that's right. If I just add 9 to the right side of the equation, I'm actually changing the equation. I'm not allowed to do that. So in order to not change the equation, I have to add the positive and the negative of that new number. Okay. Now, why did I do this at all? It's because of my PST. Write the perfect square trinomial as the square of a binomial. What does that mean? This is my PST, my perfect square trinomial. On the side, let's write down, we have, this is my perfect square trinomial, and I can factor it as the square of a binomial. Do you remember? Okay, if you remember, write down what it is squared. We take the square root of the first term. We take the square root of the last term. And I take the sign that is in the middle. This is how we factor a perfect square trinomial. Kind of familiar? Totally familiar? Kind of familiar? Need to review? Okay, you'll do some of this in your homework. So now I'm going to add a set of brackets, right? Because I want to show that I used the first 3 terms to factor it into a binomial squared. But I still have that -9, right? I didn't change that. And I still have that +8. I didn't change that. Stop me if you're like, how'd you get that? Where did that come from? And I'm trying to keep it color-coded so you can see where things are coming. Now, at this point, I'm just going to expand to remove the square bracket, meaning I'm going to get rid of the square bracket, not the orange one. I want it because that's starting to look like vertex form. When I get rid of the bracket, I'm just left with -9 +8. And now I can simplify that. -9 + 8 is -1. Can we find the vertex? Let's write it down. Vertex, -3, -1. Doesn't look like the original equation, right? We couldn't have found this vertex just by looking at the standard form. Okay, let's try this again, but now I'm going to add an a value that doesn't equal to 1. And this is where the partial factoring comes in. So now my standard equation looks like this. 3x squared minus 12x plus 11. I'm following all the same steps, but because of that 3, I need to add one more step. Okay, step 1 was group the terms containing x using square brackets. So only the 2 that have an x get the square brackets. This is the beginning of partial factoring. Second, factor out the coefficient of x squared. That is also part of partial factoring. What is the coefficient of x squared? 3. Okay, so that means I'm going to divide everything by 3. Right, so now I'm going to have y equals, I'll put the 3 out front, and whatever's left over goes inside the square brackets. So 3 divided by 3 cancels out, x squared. Negative 12 divided by 3 is negative 4x. Close the bracket. Don't forget that plus 11. Is this partial factoring? You did this with Mr. Alexander? Yeah, question.
Isn't the greatest common factor 3x?
It is, but we're not doing the greatest common factor because we need the x in there because so that the vertex form has an x in it.
Okay.
So we're just it's not greatest common factoring, it's partial factoring. Just the coefficient. Yeah. Okay, now we're going to find that number. All right. So take the coefficient of x. The coefficient of x is negative 4, right? We take the coefficient of x after partial factoring. What do we do to it? We're going to divide it by 2 and square the whole thing. Okay, negative 4 divided by 2 is negative 2. Do you see my beautiful brackets? Because if I didn't have brackets, I might say, oh, the answer is negative 4. But it is positive. So in this case, the coefficient and the number we find are the same value. That happens sometimes. 3b. You then add and subtract that number inside the brackets. Okay, y equals, I'm going to keep my 3 green, x squared minus 4x. And now I take that purple number and I add it and subtract it. And I'm always adding it first because that's what I need for the perfect square trinomial. So the 3 out front is just kind of hanging out. Next, I will take these 3 terms, which are my perfect square trinomial. I'll factor them in one step because I know I take the square root of the first term. What's the square root of x squared? Hey everyone, what's the square root of x squared?
Yes.
Hey everyone, what's the square root of 4?
2.
And am I going to put a plus or minus in the middle? Excellent, because I look at the middle term. Okay, so that's my perfect square trinomial factored. Now I need to add everything that I didn't change. I didn't change that 3. I didn't change that 11. I still need to add my y equals, or at least an equal sign. Folks, we're starting to get there. Expand to remove the square bracket. What that tells us is we're going to go 3 times this binomial, 3 times minus 4, so that we can remove the square brackets. So if I go 3 times the orange binomial, it just looks like this. And if I go 3 times negative 4, it looks like that. And the 11 is still just hanging out. not being changed. And now we do this just simplifying, like i.e. do the math, right? So I don't touch the first part because that's looking like vertex form. I want it to look like this. But I see that I have to multiply -4 times 3. And I have to add 11. And once I simplify, it's like, hey, oh, look at that. What a cute little equation. Isn't it cute? Come on, it's cute. What's the vertex? Hey, I can even find the vertex. 2, -1. Can I graph it? What's my step pattern going to be? It's going to be 3. Okay, 1 times 3. 3 times 3 is 9. 5 times 3 is 15. Oh my gosh, I can graph the whole thing. Folks, these are the steps of completing the square. And yes, of course, we have homework just because I care so much. So look at the table of contents. Don't look at this. Okay, look at the table of contents and do 20, 30 minutes of completing the square. So that tomorrow when I send you to the board at the beginning of the lesson, you can at least as a group complete the square for 2 of these types of questions. We good? Are you thrilled that you have homework today? Absolutely. Great.